Alright, so in this video we're going to commence videos on quizzes starting with stoichiometry. So these questions are compiled from past papers. Okay, so this will help you build confidence under every topic, and of course let's get started. So let me just show you the questions we're going to answer. So first of all, we're going to do the multiple choice questions, as you can see, all the way up to, I think I've got about 16 or 17 of these. All these are coming from exam papers, and then section B form questions, and then the majority are section C form questions. That's a question from back titration. You can see another question there, and then that's another question on redox titrations. These are section C form questions. Okay, so we're going to answer all these questions in this video. Okay, so feel free to pause the video and attempt the question before we move on. You can also attempt this quiz on our site using the link in the description below, where it will mark you and show you the marks and show you how confident you're getting. So number one, round up an herbicide manufactured by Monsanto as the formula C3H8NO5 and then phosphorus. That's the formula of this herbicide. Okay, round up. Now we are asked specifically to determine the number of moles of molecules that are there in the 304.3 grams sample of Roundup. So identify the data given in the question. This is mass. They want us to find the number of moles. Okay, so what can you get from that formula? Why do you think that formula was given to us? We can use it to help us determine the molar mass, right? So the mass is known, the molar mass is unknown. So the first step is to determine the molar mass. So how do you determine the molar mass? It's very simple when it comes to determining the molar mass. You just want to write down the formula, okay, one by one. So the first one we have is carbon, right? How many do we have? We've got 3 carbon atoms times 12, okay, and then we've got 8 hydrogens, okay, times 1, based on the simple periodic table I'm using. And then we've got 1 nitrogen times 14, and then we've got 5 oxygens times 16, okay. And then finally you can also do for phosphorus. If I look at my periodic table that I'm having right now, phosphorus is like 30.97 its molar mass, 30.97. so 30.97, we only have 1 of it, okay. So what you want to do there is 3 times 12, you begin multiplying, right? That's going to be 36, that's going to be 8, that's going to be 14. 5 times 16 is going to be 80, and then that will just be 30.97. So grab your calculator and add all these to determine the molar mass. We can also call it the relative molecular mass. Okay, so the value that I have on my end for the molar mass is 169.07 grams per mole. Okay, so do your math properly using your periodic table. Okay, so that's our molar mass. Very simple for us to determine. Now when you look at the formula for the units for the molar mass, that's why it's important for you to be paying attention to the units. We have grams per mole. Now we want to determine the number of moles, so the moles has to be on top. We can write that as a reciprocal. Okay, so when you say grams per mole, it's the same as grams per mole. So we've got 169.07 grams per mole. This is kind of the thing that we have. So we can write the reciprocal by putting the moles on top, because that's what we're interested in, and then the value and the grams can be on the bottom. Okay, so we don't want the grams that are on the bottom. We have to multiply by the grams so that they actually just cancel out, so that we remain with what? The number of moles. So in other terms, some of you know that the formula for determining the number of moles is what? In terms of the mass. So it's actually, you see that it's actually mass over molar mass. Of course, it's a different issue when you go to the solutions. You'll see that it's actually a product of concentration and volume. So therefore, the grams will just divide, and then 304.3 divided by 169.07. What value are you getting? I'm getting 1.79 moles. Okay, now check your solutions there. On our solutions, it's not there. So if we round off this, it's going to be 1.8, right? 1.8 moles. So that gives us B as our perfect solution, right? Yeah. Now move to 2. 2 says sodium hydrogen carbonate is the active ingredient in baking soda. How many grams of oxygen are in 0.42 grams of that? This is just a simple question. How many grams of oxygen? So sodium hydrogen carbonate is what we have. They want us to determine the mass of oxygen, given they've given us the mass of a compound, right? Now this is just like coming up with a ratio. How many oxygen atoms do we have there? We've got 3 oxygen atoms. And then the molar mass of the entire compound as well can be written. Multiplied by the mass of the whole compound. This is like they say, they give you the percentage, right? Concentration of something. They say oxygen is like 10% of the sodium hydrogen carbonate. What is its mass given that the mass of sodium hydrogen carbonate is that? That's a similar question. So we're just going to come up with the ratio. We've identified that we've got 3 oxygen atoms there now, divided by the entire molar mass there. So equally we have to determine the molar mass of the entire compound. Now I don't have to show you that. You know sodium is 23, the molar mass on the periodic table, that's 1.008. This is 12.01. This is 16 times 3. Okay, the others is just times 1. So you're going to have 23 plus 1 plus 12 plus 48. Okay, so that will be able to give you the molar mass. Okay, so let's just do the basic calculation there. Okay, where is my calculator? So 23 plus 1 plus 12 plus 48. 23 plus 1 plus 48. So I'm getting 84 grams per mole approximately as the molar mass, right, of the whole compound. Now we've got 3 oxygen atoms on top, so that will be 3 times 16. That's going to give us 48. So 48 over the total 84. All these are grams per mole, so the units will just of course cancel out. And then multiply by 0.42 grams, which is the mass of the compound. So these will divide. Now 48 divided by 84, and then multiply by 0.42. Okay, we'll get 0.24 grams, which is exactly B. Okay, cool, right? So let's move on. Alright, so we'll pick it up from the third question. What is the mass of 4 atoms of copper in grams? What is the mass of 4 atoms of copper in grams? So the question is, we have to find the mass, okay, of 4 atoms. So whenever you see the aspect of atoms, molecules, ions, number, just always be reminded of the Avogadro's constant, okay? 6.022 times 10 to the power 23. The units are whatever you're talking about per mole. So in this case, we're talking about atoms. So atoms per mole. The units vary depending on what you're talking about. So the idea here is every mole is going to contain that number of atoms. That's Avogadro's constant in this case. Now we are specifically talking about copper. Now we can get the molar mass from the periodic table for copper, which is approximately 63. So which is 63.546. The units for molar mass are grams per mole. So you see that Avogadro's constant is giving us the number of atoms in a mole, and then the molar mass is giving us the grams per each mole. Okay, so in other terms, you can actually equate these. So you say 6.022 times 10 to the power 23 atoms, okay, and then those atoms weigh 63.54 grams. The reason is simple. In short, we've got the moles on both sides, and so we can just easily cancel them out, right? That's exactly what's happening there. Then what else? The other thing we have is they want now us to determine that for the 4 atoms. These number of atoms weigh that much by just comparing the Avogadro's constant and the molar mass. How about 4 atoms? It should weigh very, very small, right? So you put an X there, and then of course cross and multiply. What do you end up with? So you see that the 4 will multiply with that. So that will be 4 multiplied by 63.54 and grams. Grams multiplied by atoms, right? And then we'll divide by 6.0222 times 10 to the power 23, and then atoms. So atoms will just like go, so that you just remain with your grams. So you can see that your answer is going to be 4 multiplied by that, then divided by the Avogadro's constant. So approximately the answer is 4.22 times 10 to the power negative 22. Now grams, giving us the perfect answer to be C. Okay, so whenever you see under stoichiometry any calculation that deals with the number of atoms, number of molecules, just always be reminded of Avogadro's constant, and the units are always molecules per more, atoms per more, ions per more, depending on what you're talking about in that very specific question. Question 4. The manganese oxide ion, I hope that's the correct name, yeah, is often used to analyze the ion content in aqueous solution via the reaction. So we've got a balanced equation there for us. All we are trying to answer is what is the ratio of this ion to that ion in the balanced equation. Let's identify them. Pause the video to identify them. Okay, so it's this guy and that guy. So what ratio are they in? So please pay attention, don't be deceived. Pay attention. That's 3 plus ion. These are 2 plus ions. So this is 2 plus. So that's going to be 5 to 1, right? D. Now question 5. The recommended limit for self-exposure to sulfur dioxide is that should be exposed that much. What is the concentration in parts per million, ppm? So this is just requiring you to determine what actually you're talking about. So we use these units like ppt, ppm, ppb, just to help us understand the small values, because I mean, if I say 0.0000, you don't understand what that means. I know you know it's small, but it doesn't make sense to you, right? So these ones help us understand that. So parts per thousand multiplied by 10 to the power 3, parts per million 10 to the power 6, parts per billion 10 to the power 9. Now they want us to convert that to parts per million, so we'll just multiply that value times 10 to the power 6, so that we add the units ppm. So the decimal point is going to move how many times? 6 times. 1, 2, 3, 4, 5, 6. So that will be 25. To no longer be a percent, but 25 ppm. Okay, which is A, right? Okay, so at least you'll know, okay, there are 25 parts per million, so at least you can tell it's more, and it can at least make more sense than looking at the recurring zeros there that don't make sense to us. Now, one of the most interesting questions is question 6. Which solution among the following does not contain the same total number of ions? I removed moles because the moles is obviously very easy. When you are comparing this number of moles, you just of course determine, right? You know, number of moles is product of concentration and volume. Then you'll be able to determine the number of moles and compare the answers. Now, the issue of the number of ions is totally different. Okay, not very different, but totally different from the or aspect. So I'll start with A. We're given decimeter cubed there, and then multiplying by 0.10, that's the concentration. So we're able to determine the number of moles to start with, right? So number of moles, we're going to multiply the volume, right? So we're going to multiply our volume, and then we multiply it with the concentration. Okay, so the units are clear there. So we have 10 decimeter cubed multiplied by 0.100 moles per decimeter cubed. So a decimeter cubed will definitely, of course, cancel out, so that you just remain with the number of what? That just remain with the number of moles. So let's multiply that. We see 10 multiplied by 0.1, that gives us 1 mole. The decimeter cubed will just cancel out. For B, we have 20 decimeter cubed multiplied by 0.05 moles, also per decimeter cubed. So 20 multiplied by 0.05, so that's also giving me a 1 mole. C, 13.33, you know the units now, just leave them out. 0.05 is equal to 13.33 multiplied by 0.05, that gives us something like 0.6665 moles. And then finally for D, 20 again multiplied by 0.05. We basically understand that's also going to just be 1 more, right? So in terms of a number of moles, if a question was saying does not contain the same number of moles, then basically C would be the answer, right? Now in this case, they want us to determine the number of ions. So we've determined the number of moles. Now can we determine the number of ions? Okay, so let's break down. Sodium chloride, if dissociate into sodium ions and chloride ions, which imply there are 2 ions in the first one. So if you've got a single mole of sodium chloride, it implies when it dissociates, you're going to have this equivalent number of moles of what? Of the other ions. Now for magnesium chloride, if it dissociates, you're going to have magnesium ion and also 2 chloride ions. So you see that for magnesium, it's going to have 3 ions. There is 1 there and 2, compared against a ratio of 1. So that applies to magnesium. So where there is magnesium, we're going to use 3 ions per mole. So 1 mole there for the first one, sodium chloride, so that's going to be 2 ions per what? Per mole. For magnesium chloride, we've got 2 ions per mole. So where else do you have magnesium chloride? Even this for C as well. So actually for magnesium it's actually 3. I need to pay attention to what I'm writing. So 3 ions as well there per mole. Then for the last one, that's sodium chloride, so that would just be 2 ions per mole. So now I want to multiply that to determine the number of ions. The first one would be 2, second one would be 3, the third one 3 multiplied by 0.666 0.666, what am I, 0.665 multiplied by 3. So that's approximately 2.0004. So 2.0. And then the final one, that's also going to be a 2. So which one is different? B is clearly different, right? Because we've got a 3 right there. So that's how unique this question is, and it requires you to understand the number. Yeah, but I hope you've gotten it now. So allow me to chip in just a second. So these questions are coming from a compilation of questions from past papers that involve MCQs, Section B questions, and also Section C form questions as well, all attempted. Okay, so I just wanted to let you know to say if you want to access the full topic stoichiometry and some other topics in chemistry and other courses, chemistry, math, physics, and biology, you can use the link in the description below to learn the concepts in full, and that includes the full video to this one, and also quizzes actually to assess your understanding of whatever you're learning. Okay, so the main idea of our site is to help you learn at your convenient time, and of course make learning both interesting and easy for you. So you don't want to miss out. Use the link in the description below to sign up on our site and better your grades. See you on the other side.